looking at ways of bringing down space satellites that have now become redundant. Fleming's Textiles from Kilmarnock have been given the contract to produce special tethers that could be attached to satellites and cause them to break, so eventually they fall out of their orbit safely back to Earth. Natalie Barb has a story.
The fast-growing satellite communications industries are making space a crowded place. Over the next few years, hundreds of satellites will be launched for mobile phone communications, but some of them will break down, and unless they're brought out of orbit, they'll just be useless space junk causing congestion. But bringing them down to Earth is expensive. You need to launch a rocket to take the satellite out of orbit. But a new, much cheaper way to do this could be to use a special tether. A satellite to be brought down automatically unwinds a long tether, which will cut through the Earth's magnetic field and act like a brake. Slowing the satellite down makes it lose height, and eventually it will fall to the Earth. The cheaper method works in theory, but now preparations are underway for a full-scale test in late 1998 or early 1999. When the tether costs just 1/10 of the price of a rocket launch, scientists are hopeful that this simple method could help them to save millions of dollars in their efforts to keep junk out of space.
Michael Litton from Culane Fabrics, who's working on textile development, and Chris Welch from the University of Kingston, who's a specialist in space science, came into the News 24 studios and talked to Jackie Hardgrave.
Just tell us what sort of a fabric, what would it look and feel like?
The Terminator tether, the device for bringing it back to the satellites back to Earth, is made from knitted copper wire, or it could be gold wire, but copper or aluminium look the best bet.
So it's obviously very, very durable.
Well, it's durable, not as durable as an average textile. Its abrasion properties are poor, but it's an unusual thing, and unless you've actually held one, it's difficult to compare it with most textiles that you are accustomed to.
Oh, well, if durability is not the key, then what are its main characteristics?
Well, the main characteristics is it's a narrow net of about between 2 and 20 kilometres long, and a width of about 30 millimetres to perhaps up to 100 millimetres. And the reason for a net is that if you have just a straight wire in space, it's likely to get hit by cosmic dust at some stage, and its statistical survival time is only around about 20 minutes, which is quite useless. So you need to make a textile which is a series of wires joined together strategically, such that if some do get cut, the rest of the net holds it all together.
It's an extraordinary idea, but one you were telling me before we came on the air that NASA have been working on, and that it's almost coming to fruition now.
Certainly tethers have been around for quite a long time. There have been quite a few proposed experiments, quite a few actual experiments. There were some big ones using the space shuttle a couple of years back. There have been a number of smaller ones using small tethers deployed from rockets. Really what we're looking at here is using a tether which conducts electricity, combining with the satellite, the electricity that the satellite solar arrays generate, and the Earth's magnetic field to form what is in fact a very large electric motor. So you put current through it and you can get a force out, and in this case the force acts on the satellite and slows it down.
So it's almost like a brake in space?
Exactly, yeah.
So when do you think this will be developed to such a point that every satellite that's launched will have one of these things on the bottom, and they'll all be recoverable?
It's difficult to tell. In this particular application, it's being used for satellites which are in low Earth orbit, because it depends on the Earth's magnetic field. The further you get away from the Earth, the more ineffective it becomes. But certainly for these sort of tens and hundreds of small satellites that we're expecting to see launched over the next 2 decades, I would expect there's a distinct possibility it could become just a routine feature.
Because this is becoming more and more of a problem, this junk in space issue.
Absolutely. Humanity, as it's done before, has taken something that was relatively clean and unsullied and gone up there, and over the first 30 years or so of exploitation just left bits and pieces around up there, and it's really quite messy. And either natural occurring cosmic dust, as was mentioned, or artificial debris certainly can cause a lot of damage, not just to thin things like tethers, but to things like the space station, which will be going up later this year.
And how does putting a tether on a satellite mean that it's easier to get it back at the end of its useful life?
The key thing is, I mean, you could do this using a small rocket engine. You could deorbit it using a rocket engine just as effectively. But the point is the tether system will have less mass, and that is a big thing in space. Every time you launch something into space, you're looking to minimize the mass of it so that you can get more useful payload up there.
What stage is your product? Is it developed already, or are you got some work still to do?
Well, we obviously have some more work to do, but we have actually produced prototypes which are in America now for testing, and we're really trying to refine just what the ratio between the weight and the conductivity is to be in these things.
Another high-tech story for you now.